So in this video, I'd like to go over how we might answer a transformation question similar to the one that you have in your Maths Watch exam. So what I'm going to notice here, I'm going to observe what we're doing. So we're going from shape A on to shape B. Now, clearly shape B is smaller than shape A, but if I look at it, I can see that it's similar to shape A. I can see that it's the same shape, but it's been scaled down. Okay, so we can see, if I do that, I can see that shape A essentially becomes shape B when I scale it down. So I know, I'm just going to move this along a little bit. So I know that I have an enlargement, because an enlargement just means making a similar shape. It means you're stretching a shape to make it bigger, but keeping the proportions the same. So for example, if I imagine, let's see if I can draw a shape. No, I'll do it in a different program, if I may. So let's get PowerPoint. So for example, if I have a shape here, so if I have, say, this star shape, I call that shape A. If I make the star shape bigger but keep it in proportion, that is an enlargement and that's an enlargement by a scale factor which is clearly bigger than 1, although the direction might make it a negative scale factor. At the same time, if I keep the shape the same but make it smaller, this is also an enlargement. Okay, so it's just a bit of maths terminology. So I know because the shape is the same, but it's been made smaller in some ways, the shape is the same but it's been made smaller, that we have an enlargement of some kind. An enlargement has taken place. Now, the problem is that I can also see that some sort of rotation has taken place, because if I just grab this and I'll see if I can rotate it, we can see that a rotation, what appears as though a rotation of 180 degrees has taken place. Or actually more than that even. It looks like, no, 180 degrees, yeah. It looks like a rotation of 180 degrees has taken place. But what they're saying to us is that there is a single transformation that works. So we can't say, oh, there's been an enlargement to make it, smaller but the same shape, and there's been a rotation. We need to say that in fact there has been an enlargement by a negative scale factor. Okay, so to work out the center of the enlargement, because to fully describe a transformation I need the center, or to fully describe an enlargement I need the center, which is going to be some coordinates, and I'm going to show you how to find them. And we also need the scale factor. And as soon as we work those out, we will have finished the question. So to find the center, I'm going to draw lines from B, from the corners of B to the corners of A, which correspond. So if I look at A, the shape A, I can see that this point here that I've circled is mapped onto this point on B, okay? Because it's like, if I imagine this is like an L shape, this is sort of the bottom right part of the L, okay? I can see that those 2 points have been mapped onto each other. What I'm going to do then is draw a straight line from the point on B through the point on A. And I'm going to do this again for the other points. So if I look here, this point maps onto this point. Like that. And I'm going to do one more for luck. I can see this point on the sort of joint where we change directions maps onto this point. Like that. Okay, and what we should notice is that all the lines, let's do one more, all of the lines meet at this point here. And that is in fact the center of enlargement. And we can see the coordinates are across 7, up 4. So that means the coordinates are 7, 4. So that's going to be 1 or 2 marks, finding the center. The scale factor is really easy. We need to look at the lengths of the sides of shape A. So if I look at shape A, if I get an arrow, so if I look at shape A, this long point from the coordinates 1, 4 to 110, the longest side, I can see that that is 6 units. That's 6 units, going from 4, 5, 6, 7, 8, 9, 10. But on B, the longest side, again, I'm looking at the corresponding sides, that is only 3 units, right? 1 to 4. So I need to know, to find the scale factor, to get from A to B, I need to see what I have times by to get from A to B. So, for example, to go from 6 to 3, what have I times by? Well, we should notice that I've times by 0.5. Okay, and if you want to work that out, it's just 3 divided by 6. I've times by 0.5. So that should be the scale factor, we can check. If I look at this side on A, so this is like the top of the L shape, if you like, that is, how many units is that? That's 4. Going from 1, no, that's actually 3. Yep, that's 3 units. And if I look at the corresponding, that's 3, that's not 3, that's 2, sorry, rubbish. That's not 3, that is 2. If I look at the corresponding side on B, it's only 1, 9 to 10. And I can see that I've obviously times by 0.5 to get from 2 to 1. So that means, not just a little check for us, that tells us that the scale factor is indeed 0.5. And if you put that in as your answer, so you say it is an enlargement, that's 1 mark. The word enlargement would be a mark. Saying center 7, 4 would be another mark. And the last mark would be scale factor 0.5. So that is how we would approach this question. And it's very similar to the one that you have.